Hello, Rob. How are you?
I'm good, Chantal. How are you?
Excellent. Are you ready to talk about IPMX today?
Always excited to talk about IPMX. You know me.
I know, right? It's new and exciting. I think it's so amazing. Um, Good. So let's get to business here because we have a lot to talk about today.
Got
And
to?
yeah, and we want to get right down to business. So let's talk about this time that we're living in. We're living in a time where technology change seems to be happening all around us. It's hard to keep up, right? It's a little crazy. And this is usually for the good, but it brings about some challenges, doesn't it?
Sure does. And yeah, when technology evolves, as it continues to do so, there's always going to be challenges. I'm
Mm.
old enough to remember how component video evolved from three-wire analog, first from RGB, then YUV, and then shock horror from analog to digital as SDI started. Of course, initially it was in 4:3 SD, then widescreen, then full HD, and on it went. Same, of course, happened as analog audio went digital as well. Both of those were in the professional and in the consumer products. Then the same thing happened when mobile phones went digital. Then, of course, phones started being cameras, loads of other things too. Cutting to the chase, it's technology. Technology moves on. And, that's the life we live, isn't it? That's
We need to move with it.
we do, and I think the knock on from that is there's not much demand today in any of those areas I just mentioned for the folks who only have the skills that were current in the 80s and 90s, no matter how expert they were then. And yet there's always going to be somebody who's got issues based around the simple fact that they need to reskill. But the bottom line is changing technology means new challenges, just like you said, for all of the doers. And that's us.
Exactly. Exactly. And from where I sit, you and I aren't ready to retire yet, right?
Oh no, no, no. And if we don't rise to the challenge, we're history.
Yes, we are history. It's called continuous professional development, right? And some of people's accumulated personal career experience, certainly you and I, we've accumulated quite a bit of experience, but some of it is just not as relevant as it used to be because technology is moving so fast. So for the AV folks, what are they walking into? What sort of update do they need?
Well, I think the way AV over IP has developed, there are multiple approaches, and they often come with proprietary elements, of course, and that means they don't necessarily work with each other unless first you exit the AV over IP system as some sort of common currency, and that's usually baseband like HDMI or SDI, and then you bridge between the systems outside of the network. In other words, you patch across. And that patching process sidelines one of the biggest advantages that the network based systems have got. It's taken the asset out of the network where it was secure, where it could be monitored, where it could be routed to places that weren't necessarily part of the original plan. And noting that AV over IP is network based, that identifies the first point of our upskilling. We need to learn about networks, both generic networks, the sort that corporate has got, and the additional elements that make the networks increasingly useful for us in AV and Pro Video. The elements that the corporate IT department don't know about.
Mm, yes. So that begs the question, where are the corporate IT departments likely to have holes in their experience? What is it that the AV folks can bring to the party?
Good question. And let's be very clear. The folks in corporate IT are certainly all the ones I know, but in general, they're very good at their job. They
Mhm.
typically know everything they need to know and more. However, our particular needs in AV over IP are going to take them into territory that's uncharted for them. For example, if you ask them how is it that all the PCs on the network show the same time in the clock in the corner of the screen, they'll tell you about the network time protocol, NTP, and how it works. They know all about that. Getting all the computers to show the same time to within, I don't know, a tenth of a second is pretty clever. Unfortunately, large swathes of the AV over IP empire use a different protocol. PTP, the Precision Time Protocol. Clues in the name, it's got more precision than the synchronization that it can achieve. And we need that if we're going to sync the video. Now, that protocol, PTP, is not even mentioned in the CCNA syllabus. And going up a professional level to CCNP, it gets a mention, but not much more. So either the IT folks have got to upskill, or the AV folks have got to skill up. Someone needs to know about PTP, unless the AV challenge is so straightforward that you don't need it.
Exactly. No, definitely. And it's about continuous learning, like we said before. So I feel like IPMX gets around that, right?
It does, of course, and it does that by offering timing modes that give you options. Some are the PTP that ST2110 uses, and others are modes that ST2110 doesn't have. And that's a good idea for another podcast. We should think about that one.
Yeah. Okay. So you were talking about upskilling.
Indeed, yeah. So that's one opportunity. Another opportunity then, most AV over IP nowadays involves compression, reducing the amount of data it takes to make it easier to move or perhaps easier to store. We've all heard, I think, of MPEG-2, H.264, HEVC, JPEG, and so on. But as AV pros, we need to have more under our belt than simply having heard of it. Because if we get this wrong, people, our clients, whether they're internal or external, are going to notice, and that's going to hurt us.
Right? Of course they're going to notice. So let's talk about these network elements. If we can't lean on our colleagues in the IT department, that's an opportunity for the AP folks to add their new value, because they have a huge value, but this is a new value. So what are we going to be talking about and doing to add the knowledge pool in the AV realm, and I guess to the IT folks as well?
So we've got to talk about several subjects here. We'll start with payload. So media like video doesn't behave like regular IT traffic. It's near continuous, it's sustained. Frames come along frame by frame on a regular basis. We might perhaps say it's cyclically bursty, but it's not independently bursty. So it needs a different sized pipe to the regular IT traffic, like keyboard, mouse, internet browsing traffic, and so on. Maybe the occasional upload and download, saving to network drives, and so on. Important point. The payload doesn't depend on whether we're thinking about on-prem solutions or in cloud solutions. It's related to the content. So that's the first thing, payload. Next thing we need to think about is bandwidth, and in particular dynamic changes to the bandwidth of the pipe size, because they have an effect on the viewer's experience. Video and audio, as I said, it's a continuous thing. We immediately notice if there are gaps and discontinuities in it. There needs to be enough bandwidth available to take account of that. And video needs much, much more video than audio does. So that's two. Next one, delay, or latency as we tend to refer to it. That needs to be very low, either for interactivity reasons, say we're talking about esports or even a house of worship where people at the front are responding at a noticeably different time to the people at the back. That's not good. For enjoyment reasons, hearing next door react to something you haven't seen yet spoils the entertainment if you're watching the game.
Right.
Well, that's a good idea, trying to do a Mexican wave with next door when you can't see them.
That's right.
So that's enjoyment. Financial loss. Sometimes there's a risk of financial loss because of delay. Think about currency speculation or even bookmaker shops, gambling shops. A delay can be an opportunity for the bad people to exploit, placing a bet when they already know the result. Clearly, you don't want that. And to revisit the earlier point, of course, we need the endpoints to be synchronized, either so they're all showing the same thing at the same time, or if we're talking about a video wall, they're all presenting their part of the whole at the right time. So that's several different areas we could look at for upskilling.
Right. Nothing radically new there. Managing delay, sync, signal quality, they're all things we've done for decades, except that these things are done a different way in the new world, right?
Exactly. And there's a strong current of support towards published standards and open specifications as an ideal way of managing the diversity of needs without producing proprietary silos, because that's not seen as a good thing.
It is not. Okay, so same but different then, and a trend towards open. That brings in IPMX, ST2110, NMOS, front and center. What are some of the common compatibility issues or challenges that integrators might face with these components?
And there's going to be challenges. Let's not neglect that. Let's start with NMOS, the Network Open Media Specification that comes from ANWR, because that underpins both IPMX and ST2110. Now, it's particularly concerned with the discovery and registration in a media-centric environment.
Mhm.
Discovery and registration is not new either. That's the same but different. But there are several methodologies that are common in general IT. In order to give interoperability the best chance, what IPMX has done is narrowed the field to one. Actually, ST2110 did it as well. It's NMOS. They share that. And that's really important. Almost everything related to high-end media at a broadcast show, like NAB or IBC, does it the same way. This isn't new. It's got a huge installed base, all of those people. And it underpins the compatibility between IPMX and 2110 and opens the way to interoperability more generally.
Okay, so you said primarily used by ST2110. That sounds a little bit non-committal. Is that not required?
You're right. It sounds a bit woolly, I'd say. Let's
Woolly.
see. Let's see why. The NMOS was created after ST2110 was introduced, precisely in order to address some lessons learned from leaving it open to choice. The original ST21 installs didn't have it, so it's not mandatory. The early ones didn't have it. Nowadays, it'd be pretty odd not to use NMOS for 2110, but according to the rules, it's not actually a hard requirement.
Okay, so NMOS was added after 2110. So what did it bring to the party?
Of course, the interoperability that I mentioned is vital, but there's more. Unlike regular IT networks, NMOS doesn't build the registry inside a switch.
What's a registry? A registry in a school is really important, right? Nice analogy there. But it sounds like it's going to be important here.
It is. The registry is the logical map of the network, a list of what is where. In the standard IT approach, that list is held in one of the switching elements, the switch or the router. And there's a reason for not doing it the same way. Media devices often have multiple network ports. Let's say it's a camera. It's got one address for video, another for audio, a different one for monitoring and control, and so on. It maybe even have two network ports for the same media to enable redundancy. The switch-based registry sees those three or four independent entities. The NMOS registry, however, understands them all as being part of the same device. Now, that's really important if you're taking devices in or out of service, like that camera. You know that all of those addresses need to be changed, and you can if they're associated to the same device. That's what happens in the NMOS registry. It also determines if that particular port is for network audio or network video. It can determine whether it's inputs or outputs that it's talking about. And that's really important when you're creating streams between ports. NMOS was designed for this purpose. It was also designed for scale, including across routers. At the recent Olympics in Paris, Warner Brothers Discovery are reported to have had 300,000 NMOS endpoints in their operation. That sort of scale would challenge many of the other AV over IP approaches well beyond their capability.
Is that all? Seems like a piece of cake to me.
300,000, yeah, mere bagatelle.
No big deal. Big challenge, right? Anything else to watch for?
Like all technologies, even the mature ones, NMOS has got some wrinkles that are still being ironed out. And like most technologies today, NMOS is under the cybersecurity microscope, as everything is. But I think we can all take some solace in knowing that there are some very clever people working on this, some of whom we're both privileged to know.
Indeed, indeed. I know them too. We both know them. They're geniuses as far as I'm concerned. So that was discovery and registration. Let's move on to compatibility in moving the media. What do integrators need to think about here? Because I'm always thinking about the integrators.
Well, it doesn't work without them. Let's go back to the track we set out earlier, the bandwidth, the sync, the switching. Whilst fundamental things like uncompressed is not directly compatible with compressed, they're givens. SD2110 and IPMX have worked to make sure that the conduit, the pathway, is the same, and that makes it much easier to have gateway products that can manipulate assets between the different qualities. You can't take compressed and turn it back into perfect, but you can make it fit the expected delivery mechanism so that an uncompressed only device will accept that compressed video. And at Matrox, we've created IP gateways that do exactly that.
Hence the brilliant people that we know. So that created a bridge between uncompressed and compressed. Presumably the device would need to be 25 gigs capable, or it would never be able to create something that looked uncompressed. We're not talking about 1 gig anymore.
Exactly. So a 1 gig only device just couldn't do it.
Mm.
In order to for that uncompressed device to accept it, it's got to arrive on a 25 gig port.
Mm-hmm.
So users are also going to benefit from gateway devices that let them convert from legacy installations to whatever their AV strategy is taking them towards, even if it's not IPMX. There will be some who aren't ready for it or don't want to. They might have NDI on their cameras and need it as an SRT stream, or they might want to connect their H.264 players to H.265 receivers or whatever it is. Again, taking it out of the network isn't the best approach. So you need a network device that can transrate, transmux, transcode, transform, or whatever it is that's needed. Ideally one that can handle multiple streams simultaneously, because there's usually lots of streams moving around in our networks. And again, by not forcing early retirement of the kit, we're helping our users to make best use of their budget. So we've got compatibility between formats. Next, compatibility between manufacturers. And if they're following the IPMX standards, they will have created compatibility with other brands, the other brands offering similarly featured products. I consciously didn't say devices here because IPMX can also be software as well as hardware. So it might not be a device. And then you've got compatibility between networks. Streams can start in a network with broadcast braid PTP and then cross into networks, like a digital signage network perhaps, where there's no PTP. There needs to be some sort of bridging device.
How do network management and media transport protocols factor into the decision making for selecting IP-based components?
And that needs to be made. You need to make decisions. And either you're going to need the endpoints to have matching capabilities, or you need some sort of conversion or gateway process. AIMS is evolving a set of profiles that will make it easier to determine what should work with what when you're putting your systems together. And that's helping to exploit the interoperability of IPMX. That will largely follow the network and the codec that's being used. So one product might have a particular license as an option, whilst another might have it included. But knowing that those two devices can work together is clearly useful. The opposite might be a device that was video only and another that was audio only. They clearly are never going to work together. But we also need to think about the timing protocols like the PTP we mentioned earlier. The IPMX devices must support it if it's already there on the network. That's part of the interoperability promise with SD2110. However, in the absence of that SMPTE profile PTP, there are two other timing modes in the IPMX bag of tricks. Firstly, the IPMX endpoint is allowed to offer itself as a timing leader, less rigorous than being a full PTP grandmaster. After all, the IPMX endpoint is designed to be an endpoint. It doesn't have vast amounts of spare processing cycles to manage all the additional messages multiple times a second. And the second additional timing mode, and one that appeals to a large part of the AV industry, is to run asynchronously, meaning without correlation to the other devices. And it does that using the timestamps that are included in the RTC packets of the stream itself, combined with NTP. Not as good as PTP, but still good enough to be visually synced across multiple monitors, which is what we in AV want.
Exactly. Can you, Rob, share any tips for future-proofing IP-based systems, especially with the rapid changes and all the advancements in AV and the broadcast technology? How do we future-proof?
I think the first tip is accept that there's going to be changes in the environment around you over the lifetime of whatever it is you're integrating. So the user is going to want to bring in a technology that you don't know about today. The users don't know about it today either. So the tip is, don't design so tightly to whatever they've asked for today that you've not left yourself any maneuvering room. Design for interoperability, because the environment is changing. It's changing fast. You're going to need interoperability.
Yeah, we're talking about planning for a future that you don't know about. That's really interesting. What advice would you give to integrators who need to balance performance with budget constraints? Because that's going to happen when they're selecting IP components.
Budget constraints are nothing new, and no users want to rip out systems that have still got life in them. ROI is really important. Ripping out something that's got life left is wasting budget. So make sure you've given them ways to extend the life of a system, ways to reuse and repurpose rather than rip and recycle. And that means think about and discuss interoperability. Choose systems that support the ability to change performance level, perhaps by substituting endpoints, without materially changing the control plane. That's helping the user to get the most from their budget, the most from their investment that they've made in their own control systems.
Yeah, that's a win-win right there. Can you provide some examples of how well-chosen IP-based components can transform workflow efficiency and scalability in a ProAV broadcast environment?
Yep, I mentioned the Olympics.
Yes.
That sort of scale, 300,000 endpoints, Warner Brothers Discovery were rightly proud of that. But AV over IP is growing all around us in all of our markets. One of my personal favourites is a medical school in the UK. The trainee surgeons can learn a lot with simulation, but practical work involves individual students with real scalpels and dead bodies that have been left to science. Streaming a high-res camera feed from their colleagues' operating table lets them share experiences like never before.
I love it. I love it. I love the idea of interoperability. I love the idea of having the ability to prepare for a future that you don't know about yet, right? When you're setting things up. And I think integrators would love that idea, end users as well, and not getting rid of things that you already have, and just being able to add some endpoints as you need them.
Sum it up in a very short sentence: expect the unexpected.
Yes, expect the unexpected. I think that's perfect. And I think we will leave with that and on to our next podcast with more information soon.
Looking forward to it. See
Thanks,
you then.
Rob.
Bye now.